Yes. So my name is Mahenza James, and I'm a member of Group 19. And for our project proposal, we shall be discussing explainable artificial intelligence, deep transfer learning for skin disease diagnosis. Yes, the keywords we used in this research proposal were deep transfer learning, artificial intelligence, explainable artificial intelligence, skin disease diagnosis, and convolutional neural networks. Yes, so when we talk about diagnosis, we are basically referring to any form of treatment a given individual could receive from an AI-based system or a medical personnel. And when we also talk about the skin, we're basically looking at a body organ that is responsible for providing protection and regulating both body fluids and temperature. So in this same manner that our project aims at improving skin disease diagnosis using deep transfer learning and explainable artificial intelligence. During our research, we discovered that skin diseases actually cause a huge burden on our global context in terms of health. And the existing skin disease diagnosis methods were actually or are very costly in terms of money and time. They also require high skill and experience. And this means they are very prone to errors, therefore leading to misdiagnosis. For our problem tree, we're going to be looking at it in two ways, on the side of a patient and the side of the medical personnel. On the side of the medical personnel, it's time consuming. It requires high skill, and also that the equipment being used is quite pricey or high tech. On the side of the patients, we shall look at it in terms of mental health. It has a negative impact. Whenever you misdiagnose an illness, it has a negative impact on a patient's health, mental health. It can also lead to transmission of diseases because the disease has not been diagnosed in the right way. It can also lead to prolonged patient affliction. So for our research scope, we shall be basically looking at 10 skin disease data classes. That includes melanoma, eczema, acne, rosacea, psoriasis, contact dermatitis, to mention but a few. Yes, we shall also be looking at using deep transfer learning, convolutional neural networks, explainable artificial intelligence with techniques such as LRP, GraphLime, and GradCam. So for our literature review, we discovered, during our research, particular sources like R. Hay found out that 1.9 billion people are suffering or are being affected due to skin disease misdiagnosis. And then research carried out by the NIH, which is a National Center for Biotechnological Information, found out that the cost of treatment for people with skin cancer alone is over $1 billion US dollars. And then in addition to that, the World Health Organization conducted a research in 2001, whereby they found out that most of the diseases that were burdensome on a global scale were actually skin related.
Hello, my name is Pius Tumayaze. I'm going to be I'm going to go through the literature review, the research objectives, and research questions. So I'll start with the research questions. How can deep transfer learning be used to improve predictive accuracy in diagnosis of skin disorders? How can explainable artificial intelligence be applied to the field of dermatology to increase adoption of artificial intelligence methods in general? And how can deep learning be used to automate diagnosis of skin diseases using imagery data? And to what degree can explainable artificial intelligence justify deployment of skin diagnosis model for public use by dermatologists. So on to the research objectives. So these were our specific objectives related to research: to pre-process and prepare the dermatology dataset for model training, which will also involve pre-processing the dataset available for further research and the researchers in the community, and to test and evaluate the deep transfer learning model. Like, the whole point is to determine how good the model is at diagnosing the various 10 disease classes, and then to deploy interpretability and explainability using explainable AI techniques like LRP, GradCam, for understanding of the learned skin disease imagery features. Thank you.
Hello, this is Moisigwe Joshua, and I'm going to take us through our research contribution for now. So my colleagues have explained what the problem is all about. They have explained what our objectives are. And from all that, I think what I can say is that Jamie explained what constraints are tied up to diagnosis currently. You have things like expertise, you have time-consuming tests to be carried out, you have money involved. So what we want to do is that we want to produce a quick and fast diagnosis model that can carry out diagnosis without all these constraints tied up to a given diagnosis. We want to produce a model that can be able to accurately, precisely, and concisely give diagnosis faster to a patient, so they can do diagnosis without having to worry about all the other factors that we mentioned earlier. Hello, good evening. My name is Hall Enoch Sander, and I'm going to take you guys through the methodology. So under the methodology, we're going to look at two things. We're going to look at what tools we're going to use to carry out our research, and we're going to look at how we're going to use these tools to carry out our research. So under the tools we're going to use to carry out our research, we're going to employ the concept of deep learning, which is the heart of machine learning. And under deep learning, we're also going to take the use of a convolutional neural network, which is a type network architecture for deep learning that is mostly used for image classification. And we're also going to use a VGG16 model for convolutional neural network, which is mostly used for image. Which is mostly used for computer vision. That is to say, object classification and object recognition or detection. The other part of this methodology is how are we going to use these tools to carry out the research. So the first thing we're going to do, we're going to get the data from dummy data set source, and then we're going to pass this data through a pipeline, and this data will undergo this data will have to be will undergo a process called data preprocessing. So data preprocessing, we're trying to process this data such that it fits the model, the VGG16 model, as a result, giving us a correct prediction. So the process is, we get the dummy data, let me say an image, we pre-process the image, and the pre-processing techniques such as resizing, pixel normalization, image augmentation. After the data pre-processing, we get that pre-processed data, we pass it through our VGG16 model, and then we employ the concept of feature extraction. Under the concept of feature extraction, we freeze some hidden and zero layers of these models. After the result of this model, when it undergoes testing and evaluation, so after testing and evaluation, we pass it through an explainable AI technique. In this particular context, we're going to use GradCam, which will enable us to explain how and why the predictions are made by this model.
So I'm back here to conclude the presentation. So what are our expected outcomes from our research? Basically, our expected outcomes will be a fully trained and tested deep learning interpretable model. Basically, we want to apply GradCam to our trained model so that we can be able to explain the predictions and the outcomes, the predictions and the outcomes that are given by the model. If a model says that this is acne, then the model should be able to explain why it predicted acne. It should be able to give us the pixels that were important for its prediction of saying that that given diagnosis was acne. And basically, we also want to make sure that we implement GradCam for this model in Python probably, so that we can be able to make this happen. Those should be our expected outcomes. And then our future work, part of our future work is we want to bring together a community of dermatologists so that they can be able to help us fine-tune the model and make it better at what it does. We don't want to neglect the people who are going to be using the model in the process. So we want to have it as part of our future work to create a community where dermatologists can come on a forum and then give their views on the predictions that were given by the model. We also hope to search more into how to implement more implementation techniques, more explainability techniques like GraphLime. We want to probably see if in the future we could produce better implementations of those techniques. Currently, we didn't find many, so we want to have it as part of our future work to implement them in Python and probably open source them to the research community. Thank you.